Today, we are diving into a piece of technology that is seriously shaking things up, from the electric cars we drive to the robots in our factories. I'm talking about the axial flux motor. It's incredibly powerful, it's super compact, but designing one? Well, that's always been a massive headache for engineers. We're going to unpack that complexity and then show you a totally new way to beat it. So here's what we've got lined up. We'll start with why these motors are such a big deal, the axial flux advantage. Then, we'll get lost in the design labyrinth to really understand the challenge. After that, we'll introduce a completely new kind of conversation with research, see how it actually works, and finally, look at how this is speeding up innovation for everybody. All right, first things first, the axial flux advantage. Why is everyone in the engineering world getting so excited about this particular motor? What's the secret sauce? Well, it really all boils down to the direction of the magnetic field. On the left, you've got your traditional radial motor. Think of it like a spinning sprinkler, with magnetic energy flying outwards from the center. But on the right, the axial flux motor is totally different. The magnetic flux travels straight through, parallel to the axle, kind of like a laser beam. And that one simple change is what gives it that unique, flat pancake shape and its incredible power. And that disc-like shape is everything. It means the motor can be way shorter and lighter, which gives it this fantastic power-to-weight ratio. This high power density is an absolute game changer in places where every single millimeter and every gram counts, like, say, tucking a motor directly into the wheel hub of an EV. But, and this is a big but, here's the catch. The idea is brilliant, but actually building one of these things is insanely hard. And this brings us to what we call the design labyrinth. You see, designing an axial flux motor isn't a one-person job. It's a one-person with 5 brains job. You have to be an expert in magnetics, mechanics, thermodynamics, the list goes on. And all of that essential knowledge is scattered everywhere in thick textbooks, dense academic papers, and super complicated tutorials. The engineer's goal to somehow pull all of that together and find that one perfect, cost-effective design. It's a huge ask. Just look at this. This is just one single formula out of literally thousands an engineer has to master. This one's for something called an air gap correction factor. And it's not enough to just find the formula. You have to truly understand the deep theory behind it and know exactly when and how to use it. If you get it wrong, your motor's performance just falls off a cliff. And then there's this fun stuff, magnetic circuit analysis. As the designer, you have to take this incredibly complex, real-world object and somehow turn it into a simplified model like this one. Every single line on this diagram is a critical assumption you're making about how magnetism is going to behave, just so you can even begin to do the math. And even after all that brain-melting theory, you have to translate it perfectly into precise code for your design software. This line right here, it's defining the shape of a tiny slot in the stator. One typo, one single misplaced variable, and the whole 3D model just breaks. The level of precision you need is just staggering. It's a massive, massive challenge. But what if? What if we could completely flip the script? Instead of spending all your time digging through these sources for answers, what if you could just talk to them? This is where we start a whole new conversation. I mean, really think about that. Instead of spending weeks hunting for a formula or trying to cross-reference a dozen different papers, what if you could just ask, in plain English, hey, what do I need to know about this? This is exactly what conversational research AI does. Picture an application that's been fed a curated library of the most advanced, most trusted textbooks and research papers in the world. And when you ask it a question, it doesn't just give you a list of links to go read. No. It reads, it understands, and it puts together a single clear answer for you, synthesized from all that expert knowledge. Okay, so enough with the theory. Let's see what this actually looks like when the rubber hits the road. We're going from asking a question to actually creating something, and we'll see how different pros can get the answers they need, like right now. Let's say you're a designer working for a big auto supplier. You've got a really fundamental choice to make. How many magnet poles should this new motor have? It's a classic engineering balancing act between performance and cost. So you just ask. And bam, instantly, you get the answer. And it's not just data. It's the core trade-off spelled out perfectly. More poles gets you more torque and better efficiency, but it's going to require faster, more expensive electronics. Fewer poles saves you money on the electronics, but you take a hit on performance. The AI lays out that whole balancing act in seconds. That's work that could have taken days of research. Okay, new scenario. Now you're a research academic, and you're digging into something called cogging torque. It's this tiny, annoying vibration in a motor that you want to get rid of. You need to know the state-of-the-art methods for minimizing it. So you ask, and back come the main methods. But here's the really powerful part. It doesn't just list them. It gives you the critical context for each one. It tells you about the side effects, the constraints, the potential gotchas. It's not just telling you what to do, it's warning you about what might go wrong. That's deep engineering wisdom right there when you need it. And for our last example, let's jump into the EV industry. An engineer is deep in the zone, running calculations. She needs the exact formula for back EMF. That's the voltage a motor creates when it spins, and she also wants a quick refresher on the physics behind it. First, the AI gives her the exact formula she needs to keep going. Clean, simple, immediate. The induced voltage E is equal to the rate of change of the magnetic flux linkage lambda over time. And right after that, it serves up the foundational principle, Faraday's law. So it's delivering not just the what, the equation, but also the why, the fundamental physics that makes it all work. That is how you build real, solid understanding. So when you take a step back and look at the big picture, this is about so much more than just getting quick answers. This kind of technology completely changes the entire workflow. It accelerates the actual pace of innovation itself. It creates this really powerful new way of working. First, you enhance your own intuition by checking your ideas against gold standard research in seconds. Second, you speed up the whole process, crushing research time from weeks down to minutes. And finally, you can improvise and innovate much more freely because you can explore all those creative what-if ideas without getting bogged down trying to find the information. This really is the new way of doing things. AI, using a technique called retrieval augmented generation, basically gives you a direct line to a library of experts. It becomes your personal research assistant that's there for you at every single stage, from the first design sketch, through analysis, all the way to prototyping and manufacturing. This completely changes the relationship an engineer has with knowledge itself. So we'll just leave you with this one question to think about. What will you build when every answer from the world's most advanced research is instantly at your fingertips?